Have you ever imagined the existence of living beings capable of breathing electricity? It might sound like a scene from a science fiction movie, but reality sometimes surpasses imagination. Today, we will take you on a fascinating journey through microscopic life, where extraordinary organisms challenge the rules we thought governed life itself. These beings, despite lacking traditional lungs or a respiratory system as we know it, manage to generate energy from a source that is still difficult to conceive: electricity. Their discovery has captivated the scientific community, forcing us to rethink how we understand life and energy. Imagine being in a swampy environment rich in metallic sediments. Here, at the heart of nature, live microorganisms capable of transforming their surroundings into energy. Among these extraordinary organisms is Geobacter, a bacterium that has emerged as one of the most fascinating examples of microbial life able to breathe metals instead of oxygen. The discovery of Geobacter occurred in the 1980s, thanks to microbiologist Derek Lovely and his team, who were studying the environment of the Potomac River in the United States. This setting, characterized by low oxygen levels and metallic sediments, revealed a bacterium with exceptional abilities: the ability to use metals, particularly iron, as electron acceptors to generate energy. Unlike other organisms, Geobacter does not need oxygen to live. On the contrary, it can survive in hostile environments by transferring electrons to the iron in its surroundings. This process, technically called anaerobic respiration, allows the bacterium to produce energy even in extreme conditions. It's incredible to think that while we rely on oxygen to breathe and generate energy, these bacteria have found a completely different path. But the real magic of these microorganisms lies in their ability to form nanowires, microscopic conductive filaments that allow them to transfer electrons over long distances. These nanowires can be seen as a network of living electrical cables, enabling Geobacter to communicate and energize its surroundings. Imagine a system where living organisms can create natural electrical networks, capable of transferring energy from one point to another without any artificial technology. This discovery has raised intriguing questions. If bacteria can generate and transfer electricity, what applications might we imagine for the future? One of the most promising ideas is using these bacteria to create biosystems for energy production that are entirely sustainable, pollution-free, and capable of continuous operation by simply feeding on metals present in the environment. But to fully grasp these potentials, it's essential to examine the context in which these bacteria live and how they developed their extraordinary abilities. Geobacter thrives in oxygen-poor environments, such as river sediments and soils contaminated with heavy metals. In the absence of oxygen, these bacteria cannot rely on the typical respiratory process. Instead, they evolved an alternative strategy, using iron, which can accept electrons under anaerobic conditions. This adaptation has allowed them not only to survive, but to thrive in habitats where many other organisms would struggle. The result of this adaptation is remarkable. Not only can these bacteria survive in extreme environments, but they are also incredibly efficient at producing energy. A single colony of Geobacter can generate measurable electrical current. In laboratories, researchers have created devices that harness this ability to produce small amounts of electricity continuously. But this is only the beginning. Science is still in the early stages of exploring these bacteria's potential. Applications range from environmental remediation, where Geobacter could be used to clean up soils contaminated with heavy metals, to the creation of sustainable energy production systems capable of powering small devices or even entire buildings. In this context, biology and technology intertwine in fascinating ways. Geobacter is not only an example of unique life, but also an opportunity to develop new green technologies that could revolutionize our approach to energy production. The ability of these bacteria to generate sustainable energy might provide a solution to one of the most pressing challenges of our time: the energy crisis and environmental pollution. Imagine a world where we can generate clean energy simply by using the ground beneath our feet, where bacteria are no longer seen as pathogens to combat, but as powerful allies in the fight against climate change and the depletion of natural resources. But that's not all. Besides Geobacter, there are other bacteria that share this extraordinary ability. One of them is Shewanella, a marine bacterium discovered more recently that lives in deep marine environments and uses a similar strategy to generate energy. These organisms show us that life can find ingenious solutions to survive even in the most extreme conditions, and they make us reflect on how we might harness these abilities to solve some of the most urgent problems of our time. The discovery of Geobacter and similar organisms has opened up new perspectives for science. Some researchers are exploring the possibility of using these bacteria to build true biological circuits, living networks of electricity production and transfer capable of powering devices autonomously, without traditional batteries or external energy sources. These microbial circuits could be used in extreme environments, such as space or ocean floors, where traditional energy sources are difficult to bring, or in everyday electronic devices, reducing our reliance on fossil fuels and lowering energy costs. Another fascinating aspect of studying Geobacter is that, in the laboratory, it is possible to manipulate their DNA to enhance their ability to generate electricity. This genetic engineering opens the door to the possibility of creating bacteria specifically designed to maximize energy production. However, there are also significant challenges to address. Currently, bacteria like Geobacter can only produce small amounts of energy. To make them truly useful on a large scale, ways must be found to amplify their production or combine them with other technologies, such as solar panels or fuel cells. Additionally, the lifespan of the bacteria presents another critical challenge. While these organisms can live for long periods in extreme conditions, they are not immortal. To create sustainable energy production systems, we will need to find ways to keep these bacterial colonies alive and active for extended periods, or replace them automatically when they start to deteriorate. Despite these challenges, the possibilities are immense. As research progresses, we may witness the birth of new bioenergy technologies that could radically change the way we produce and consume energy. To explore this fascinating topic further, I recommend 2 readings that might open up new horizons for you. The first is Life by Guido Barbanti, a book that explores the evolution of life on our planet and how natural ingenuity has allowed organisms to adapt to the most diverse conditions. The second is The Science of Networks by Albert Laszlo Barabasi, a book that delves into the concept of networks and how they can be applied in different fields, from biology to computer science. Thank you for joining us on this fascinating journey. If you enjoyed it, don't forget to leave a like, subscribe to the channel, and hit the notification bell.